Actual infinity is the idea that numbers, or some other type of mathematical object, can form an actual, completed totality, namely, a set. Hence, in the philosophy of mathematics, the abstraction of actual infinity involves the acceptance of infinite entities, such as the set of all natural numbers or an infinite sequence of rational numbers, as given objects. This is contrasted with potential infinity, in which a non-terminating process produces an unending, infinite, sequence of results. But each individual result is finite and is achieved in a finite number of steps. Aristotle's potential-actual distinction. Aristotle handled the topic of infinity in physics and in metaphysics. He distinguished between actual and potential infinity. Actual infinity is something which is completed and definite and consists of infinitely many elements. Potential infinity is something that is never complete. More and more elements can be always added, but never infinitely many, for generally the infinite has this mode of existence. One thing is always being taken after another, and each thing that is taken is always finite, but always different. Aristotle, Physics, Book 3, Chapter 6. Aristotle distinguished between infinity with respect to addition and division, but Plato has two infinities, the great and the small. Physics, Book 3, Chapter 4. As an example of a potentially infinite series in respect to increase, one number can always be added after another in the series that starts 1, 2, 3. But the process of adding more and more numbers cannot be exhausted or completed with respect to division. A potentially infinite sequence of divisions starts e.g. as 1, 0.5, 0.25, 0.125, 0.0625, but the process division cannot be exhausted or completed. For the fact that the process of dividing never comes to an end ensures that this activity exists potentially, but not that the infinite exists separately. Metaphysics, Book 9, Chapter 6. In mathematics, the infinite series 1 plus 1/2 plus 1/4 plus 1/8 plus 1/16 plus is an elementary example of a geometric series that converges opposition from the intuitionist school. The mathematical meaning of the term actual in actual infinity is synonymous with definite, completed, extended or existential, but not to be mistaken for physically existing. The question of whether natural or real numbers form definite sets is therefore independent of the question of whether infinite things exist physically in nature. Proponents of intuitionism, from Kronecker onwards, reject the claim that there are actually infinite mathematical objects or sets. Consequently, they reconstruct the foundations of mathematics in a way that does not assume the existence of actual infinities. On the other hand, constructive analysis does accept the existence of the completed infinity of the integers. For intuitionists, infinity is described as potential. Terms synonymous with this notion are becoming more constructive. For example, Stephen Klein describes the notion of a Turing machine tape as a linear tape, infinite in both directions. To access memory on the tape, a Turing machine moves a read head along it in finitely many steps. The tape is therefore only potentially infinite, since while there is always the ability to take another step, infinity itself is never actually reached. Mathematicians generally accept actual infinities. Georg Cantor is the most significant mathematician who defended actual infinities, equating the absolute infinite with God. He decided that it is possible for natural and real numbers to be definite sets, and that if one rejects the axiom of Euclidean finiteness, then one is not involved in any contradiction. The philosophical problem of actual infinity concerns whether the notion is coherent and epistemically sound. History. The ancient Greek term for the potential or improper infinite was apeion, in contrast to the actual or proper infinite aphorismenon. Apeion stands opposed to that which has a peris. These notions are today denoted by potentially infinite and actually infinite, respectively. Anaximander held that the apeion was the principal or main element composing all things. Clearly, the apion was some sort of basic substance. Plato's notion of the apion is more abstract, having to do with indefinite variability. The main dialogues where Plato discusses the apion are the late dialogues Parmenides and the Philebus. Aristotle sums up the views of his predecessors on infinity thus: only the Pythagoreans place the infinite among the objects of sense, and assert that what is outside the heaven is infinite. Plato, on the other hand, holds that there is no body outside, yet that the infinite is present not only in the objects of sense but in the forms also. The theme was brought forward by Aristotle's consideration of the apion in the context of mathematics and physics. Infinity turns out to be the opposite of what people say it is. It is not that which has nothing beyond itself that is infinite, but that which always has something beyond itself. Belief in the existence of the infinite comes mainly from 5 considerations: from the nature of time, for it is infinite; from the division of magnitudes, for the mathematicians also use the notion of the infinite. If coming to be and passing away do not give out, it is only because that from which things come to be is infinite. Because the limited always finds its limit in something, so that there must be no limit. If everything is always limited by something different from itself, most of all, a reason which is peculiarly appropriate and presents the difficulty that is felt by everybody, not only number but also mathematical magnitudes and what is outside the heaven are supposed to be infinite because they never give out in our thought. With magnitudes the contrary holds. What is continuous is divided ad infinitum, but there is no infinite in the direction of increase. For the size which it can potentially be, it can also actually be. Hence, since no sensible magnitude is infinite, it is impossible to exceed every assigned magnitude, for if it were possible there would be something bigger than the heavens. Our account does not rob the mathematicians of their science, by disproving the actual existence of the infinite in the direction of increase, in the sense of the untraversable. In point of fact they do not need the infinite and do not use it. They postulate only that the finite straight line may be produced as far as they wish. Scholastic Philosophers. The overwhelming majority of scholastic philosophers adhered to the motto infinitum actu non data. This means there is only a potential infinity but not a actual infinity. There were exceptions, however, for example in England. It is well known that in the Middle Ages all scholastic philosophers advocate Aristotle's infinitum actu non data as an irrefutable principle. The number of points in a segment 1L long is its true measure. Actual infinity exists in number, time and quantity. During the Renaissance and by early modern times the voices in favor of actual infinity were rather rare. The continuum actually consists of infinitely many indivisibles. I am so in favor of actual infinity. The majority agreed with the well-known quote of Gauss. I protest against the use of infinite magnitude as something completed, which is never permissible in mathematics. Infinity is merely a way of speaking, the true meaning being a limit which certain ratios approach and definitely close, while others are permitted to increase without restriction. The drastic change was initialized by Bolzano and Cantor in the 19th century. Bernard Bolzano, who introduced the notion of set, and Georg Cantor, who introduced set theory, opposed the general attitude. Cantor distinguished 3 realms of infinity: the infinity of God, the infinity of reality, and the transfinite numbers and sets of mathematics. A multitude which is larger than any finite multitude, i.e., a multitude with the property that every finite set of members of the kind in question is only a part of it, I will call an infinite multitude. There are twice as many focuses as centers of ellipses. Accordingly, I distinguish an eternal uncreated infinity or absolutum which is due to God and his attributes, and a created infinity or transfinitum, which has to be used wherever in the created nature an actual infinity has to be noticed, for example, with respect to, according to my firm conviction, the actually infinite number of created individuals in the universe as well as on our earth and, most probably, even in every arbitrarily small extended piece of space. One proof is based on the notion of God. First, from the highest perfection of God, we infer the possibility of the creation of the transfinite. Then, from his all grace and splendor, we infer the necessity that the creation of the transfinite in fact has happened. The numbers are a free creation of human mind. Classical set theory. Classical set theory accepts the notion of actual, completed infinities. However, some finitist philosophers of mathematics and constructivists object to the notion. If the positive number n becomes infinitely great, the expression 1n goes to naught. In this sense one speaks of the improper or potential infinite. In sharp and clear contrast, the set just considered is a readily finished, locked infinite set, fixed in itself, containing infinitely many exactly defined elements, none more and none less. Thus the conquest of actual infinity may be considered an expansion of our scientific horizon no less revolutionary than the Copernican system or than the theory of relativity, or even of quantum and nuclear physics. To look at the universe of all sets not as a fixed entity, but as an entity capable of growing, i.e., we are able to produce bigger and bigger sets, maintains that a veritable continuum which is not enumerable can be obtained as a medium of free development, that is to say, besides the points which exist on account of their definition by laws, such as E, pi, etc. Other points of the continuum are not ready but develop as so-called choice sequences. Intuitionists reject the very notion of an arbitrary sequence of integers, as denoting something finished and definite as illegitimate. Such a sequence is considered to be a growing object only and not a finished one. Until then, no one envisioned the possibility that infinities come in different sizes, and moreover, mathematicians had no use for actual infinity. The arguments using infinity, including the differential calculus of Newton and Leibniz, do not require the use of infinite sets. Owing to the gigantic simultaneous efforts of Frege, Dedekind and Cantor, the infinite was set on a throne and reveled in its total triumph. In its daring flight, the infinite reached dizzying heights of success. One of the most vigorous and fruitful branches of mathematics, a paradise created by Cantor from which nobody shall ever expel us, the most admirable blossom of the mathematical mind and altogether one of the outstanding achievements of man's purely intellectual activity. Finally, let us return to our original topic, and let us draw the conclusion from all our reflections on the infinite. The overall result is then, the infinite is nowhere realized. Neither is it present in nature nor is it admissible as a foundation of our rational thinking, a remarkable harmony between being and thinking. Infinite totalities do not exist in any sense of the word. More precisely, any mention, or purported mention, of infinite totalities is, literally, meaningless. Indeed, I think that there is a real need, in formalism and elsewhere, to link our understanding of mathematics with our understanding of the physical world. Georg Cantor's grand meta-narrative, set theory, created by him almost single-handedly in the span of about 15 years, resembles a piece of high art more than a scientific theory. Thus, exquisite minimalism of expressive means is used by Cantor to achieve a sublime goal, understanding infinity, or rather infinity of infinities. There is no actual infinity, that the Cantorians have forgotten and have been trapped by contradictions. A consequence of this is that the natural numbers of today are not the same as the natural numbers of yesterday. There are at least two different ways of looking at the numbers. as a completed infinity and as an incomplete infinity. A viable and interesting alternative to regarding the numbers as a completed infinity, one that leads to great simplifications in some areas of mathematics and that has strong connections with problems of computational complexity. During the Renaissance, particularly with Bruno, actual infinity transfers from God to the world. The finite world models of contemporary science clearly show how this power of the idea of actual infinity has ceased with classical physics. Under this aspect, the inclusion of actual infinity into mathematics, which explicitly started with G. Cantor only towards the end of the last century, seems displeasing. Within the intellectual overall picture of our century, actual infinity brings about an impression of anachronism.